This is lesson 2 in our course in troubleshooting. We began the course last time with the assembly of a digital multimeter, and we did section A, which dealt with the meter display assembly, and we also did some testing to make sure that that was functional. In this lesson, we're going to take a look at section B, which deals with the DC voltage and current circuit assembly. Let's go to section B on page 14 of this PDF file, but that's actually page 13 on your paper copy. You'll find in your kit a bag of parts labeled section B, and this contains the parts that we need to assemble this next section. I'd like you to take a look at the contents of this bag and make sure that you have all the parts. And if anything's missing, if you could report that to your lab supervisor so we can get your replacement parts. In the bag, you'll see a variety of resistors of different values and tolerances. There's also a new thing here called a potentiometer, a couple diodes in the bag, and a transistor. And then some miscellaneous hardware. There's some pictures of what those things will look like, so help you find them. The potentiometer looks like this. It's actually a variable resistor. It's going to be used to calibrate our meter for voltage and current readings. This piece of wire that's included in our parts bag is called a shunt wire. It's really just a piece of material that has a fairly low resistance. The meter is actually going to measure the voltage across this wire and use it to determine the current that's flowing through it. This can require some measurements and maybe some resoldering as we go into calibration for our readings and current. As I mentioned last time, there's a legend on the printed circuit board that shows the name of the components and actually a simplified picture of it. For instance, here is the symbol for a diode. It has a bar on one side, and that corresponds to a darkened band on the unit. A diode is a device that lets current flow in one direction. We're going to solder the components on the side of the printed circuit board with the printed name and symbol. So go through this carefully and make sure your solder connections are good and that your iron is cleaned and tinned properly. Now when you insert this shunt wire, it's actually going to go over here on the printed circuit board. They're going to recommend leaving about 1/4 inch of spacing when you solder the two ends. We're going to take a measurement shortly, and we may have to unsolder this and move this around a little bit to get a more accurate reading on our meter for high current. Now when you finish all this assembly, there's a series of tests, like there were last time, to determine if your multimeter is working, but also now that it's accurate. Now some of the components that they've recommended here to hook up are fairly simple and can get you fairly close in terms of an accurate reading, but in our AE makerspace we have some fairly sophisticated instruments. We're going to use those to get a much more accurate calibration of our unit. In the description of the YouTube video is a link to this document, which is a lab experiment for doing the calibration and testing of your digital multimeter. So let's hear some of the equipment that we're going to be using to do the calibration and some of the parts that we're going to need to do that. The room supervisor will help you with locating some of these. If you've never done any electronics work before, I prefer that you ask the room supervisor to help you through the tasks in this lab experiment. If you have some experience, you can proceed on your own. In our makerspace room, there are several lab benches with equipment on them. You need to find a lab bench that looks something like this picture in figure 1. What I need is this test equipment to be fairly close to each other. The stations are separated by quite a bit of distance, actually on the other side over here. You have to hook up wires between these things, and it's going to be very difficult if they're not close to each other. On page 15 of your assembly instruction manual is a series of tests for calibrating and determining whether your meter is working for DC voltages. The piece of equipment we're going to start out using is a 3630A multi-output power supply. What this is really a variable battery. Turning this knob, we can adjust this voltage from 0 to 20 volts. By turning this knob, we can adjust this voltage from 0 to 5 volts. And then likewise, we can adjust this from 0 to minus 20 volts. In electronics, we have schematic symbols to describe pieces of equipment and parts that are simplified versions of what we have as a picture here. The symbol for a battery looks like this. You may have seen this before. Plus and minus sign, that corresponds to, in a particular case, the plus 20 and then the common. What we'll be able to do is set the value of the voltage here. The meter below this one here is a precision digital multimeter. It's model number 34401A. It's a fairly expensive instrument. It's around $1,000. So it has a lot more features and precision that we have with our digital multimeter. We're going to use it to help calibrate our meter. Now there's a high input and a low input here, and that's really the plus and minus of this when we're using it as a voltage meter. The symbol for a voltmeter is a circle with a V inside of it. Our digital multimeter can also be used as a voltmeter, and this too is our plus and minus of that meter. Plus is called V ohms and capacitor. Those are inputs that can go in that terminal, which is over here. And then the common is the negative side of this. We're going to hook these up, what we call in parallel. Bring a wire from the 20 to the high and to the voltage ohms input. And then the other side, the minus sign, going to the low and then going to the common terminal. I'll let you read through the procedural steps here. I'll have you varying the potentiometer to get the same readings on both meters. In the next section, also on page 15 of your paper copy of the manual, is a series of tests for checking the current scales on the digital multimeter. If you set up the voltmeter correctly, you don't need to do any more adjustment for the current meter, but we want to verify that the meter works on all of its scales. In this particular case, we're going to hook up the DC power supply with an ammeter in series with another ammeter through resistance. The voltmeter looks like an open circuit when you connect it across something. In other words, it has no effect. An ammeter is hooked up, and we call in series. It too has no effect on the circuitry. It's a fairly low resistance. It too has a plus and minus sign, and if current flows in this direction, we'll get a positive reading. If it flows in this direction, we'll get a negative reading. This is the plus and minus sign on the display. So again, we're going to come out of the plus terminal of our supply. We're actually going to go to the current input, which is our plus sign, come out of the low, which is the minus sign, and then go into our digital multimeter, its positive input, which is labeled microamp, milliamp, and then come out of its negative side or common side. Use a series of things called an alligator clip here to make a connection to a resistor. What's happening is that this voltage is effectively in parallel with this resistance. And what that means is that the current that's going to flow can be calculated by a thing called Ohm's law, which is the value of this voltage divided by this resistance. The value is important, but actually with this precise digital multimeter, you'll be able to read the value of current. And so we're going to try to get these two meters to have the same reading on them. There will be no adjustments to the components in this part of it. We're going to just verify that everything's working. The last test that we need to do is for high current measurement. This is described in section C. We're actually going to change the power supply to another one that's labeled 3611A. So this goes up much higher in current than the previous power supply, but pretty much the same kind of connection. We have a plus and minus sign, which is actually over here and here. And what this is acting like is a current source. We're going to use pretty much the same setup we had before, except that we're going to take the resistor out and just put a wire back through here. Set this meter up to actually be a constant current source, and what that's going to do is pump a current through our precise digital multimeter and then through the one that we're building. The two meters should read the same values. When you're on this high current scale, what you're doing is pumping current through that shunt wire. And depending on where it's soldering, it has a certain amount of resistance. We're going to have to move that around a little bit till these two meters have the same reading on them. Notice in some of these connections with wires, I've labeled some wires as red and black. I tend to put things out of the plus terminal with a red wire and then on the minus terminal with a black wire. That doesn't really make any difference when you hook these things up, but when you're trying to troubleshoot something, if things are color-coded, it makes it a little bit easier to follow what's going on, or if you've done something in the past and come back to it, it's a quick way to be able to identify what's going on. And this is lesson 2 in our troubleshooting course.